Okay, so for today's medical moment, we're going to talk about cardiac arrhythmias. As you know, the heart is a pump. It's a big muscle. And muscles contract when electrical rhythms tell them to contract. If I want to bend my arm, my brain sends an electrical rhythm to my arm and I contract my arm. The heart is also contracting because of electrical rhythms that are coming from the brain. It just so happens that you don't have to think about it, because the part of the brain that's in charge of telling the heart when to contract is not the part that we have conscious control over. But it is nonetheless run by electricity. And the way it works is that the nerve from the brain goes to the top of the heart, called the atrium, and it stimulates the top of the heart, the muscle, to contract. And it contracts, and then it relaxes, and its friend, the bottom of the heart, the ventricle, takes turns, and it contracts, and it relaxes. And it turns out that after the first nerve comes and stimulates the heart muscle, the way that the other heart muscle fibers that are the next door neighbors get their stimulation is by contact. Oh, the neighbor contracted, we should contract too. And so there's actually a wave of contraction that starts in one particular spot and then sweeps over this top portion of the atrium, so that it contracts in the same, starting in the same place, with the contraction going in the same way every time. And it's coordinated that way. So it is squeeze. If it started somewhere else, it may not be as efficient in its contraction. And of course, the whole point is we're trying to move blood. Well, if you look at a heart, it looks like one big thing from the outside. And if there was no separation between the top and the bottom of the heart, then that nerve that started the heart to contract at the top would then cause the entire heart to contract at the same time. And we don't want that. We want the top and the bottom, the atrium and the ventricles, to take turns. So it turns out that there's an insulator that stops the connection of contraction between the top and the bottom. And after the top part of the heart contracts, all of that impulse goes to one location, and then the whole thing starts over again. So that the bottom part of the heart also, the contraction starts in the same location, and it then sweeps over the muscle in a coordinated fashion. And if you listen with a stethoscope, when you're listening to a normal heart, you hear lub-dub, as the atrium and the ventricle take turns contracting. Sometimes other parts of the heart contract out of turn. And if they do that, instead of a nice coordinated contraction, all kinds of funny things can happen. And it sounds funny, and when you hear something that sounds funny, it is an arrhythmia, meaning not a regular contraction, not a regular rhythm. Arrhythmia means not a regular rhythm. And on an EKG, which is an electrical view of what the heart is doing, we would normally see a P wave. You guys have seen this before, right? Can you pull up an EKG? In fact, you can pull up that dog's EKG. I think we have some normal beats there. Which is that first little bump, that's the atrium. And then the next big zigzag is the ventricle contracting. And then if you look, there's another little bump after that, that's the ventricle relaxing. And it's always supposed to go in order. P wave, QRS, T. P wave, QRS, T. The atrium is also relaxing, but it happens right in the middle of the contraction of the ventricle, so you don't see it. So it's not part of a normal electrical rhythm. There's all kinds of ways that this system can go wrong. Sometimes the trouble is with electrolyte imbalances, and these nerves and muscles require certain levels of electrolytes to conduct their signals. So for example, potassium changes affect the nerve conduction, so the whole thing doesn't start off like it's supposed to. Or sometimes part of the heart is misbehaving, and we're having the bottom of the heart beating out of turn. We didn't prepare our images ahead of time. That's okay. And so if it's beating too fast, that's called tachycardia. If the ventricle, the bottom part of the heart, is beating completely separate from the top part of the heart, that's a ventricular tachycardia. Sometimes, instead of starting at the top, it starts in the middle, and then it's not the right shape at all. Here's a normal PQRS. So this would be the atrium contracting, this is the ventricle contracting, this is the ventricle repolarizing, getting ready for the next one. Sometimes this just stops altogether. There is no atrial activity. Or the atrium is just doing its own thing. Atrial fibrillation is the term for that. And instead of having a nice bump, you just sort of have like jello. It's just bouncing, right, on the electrical rhythm. The particular dog that started this conversation was having times when there was no P and the QRS were coming in prematurely, out of turn. So the ventricle was beating on its own. And often when that happens, it's because there's something about the ventricle that is an irritant, so to speak, that is triggering the contraction. So premature ventricular contraction is sometimes caused by a thing, a lump, a mass, a tumor, some dead cells, some overactive nerves, but some physical problem in the muscle of the heart. And we try to manage these with medication. Depending on the situation, if the problem is that there is no regular pacemaker, it can be replaced by a mechanical thing, by a spark plug. And people who have poor pacemaking ability in their atrium, they actually get a thing with a battery and a shocker, which is called a pacemaker, installed so that it is the irritant that replaces the normal function of what would normally be done by the nervous system. That's kind of vague, that's kind of top level. We're probably not ready for the details unless you're ready to sit down and take the class. Okay, good, that's enough.